Hello, middle school. This is the 7th grade math lesson for the week of October 25th through 29th. It is lesson number 8. If you have additional lessons in your packet, those are makeup work from earlier in the year. They can be completed for grades for last quarter. This lesson, however, goes into our next quarter. So first up, things that you'll need to do this lesson with me. You will need a pen or pencil, or maybe you have a special pencil. But you'll need something to write with. You will need the homework itself, and it will be useful to have a piece of scratch paper. If you would like to use graphic paper, that's just fine. Blank paper is just fine. Just something that you can do your work on. Yeah, to get started, let's put our name on this in case it gets separated from the rest of the work, and I need to figure out who it belongs to. Next up, we are starting the lesson on slope. This is one of the more important concepts of math, and we will be using this all the way up through calculus, so this is one of those lessons that is important to know. This week we are focusing on slope. Slope is how much something changes in the x-axis versus how much it changes in the y-axis. If something is changing going up quickly, that is a high slope. If something is going down, it has a negative slope. Slope is the relationship between the change in x compared to the change in y. This is the definition I actually want you guys to pay attention to. Slope equals the rise over the run, which is the change in y over the change in x. So, y1 minus y2 over x1 minus x2. If you guys remember me telling you that what you were learning about proportional relationships was a lie, this is where it becomes important that you guys understand that it was a lie, because the proportional relationship here does not depend upon where on this line we are. We do not have to start at the origin. We do not have to have y1 equal 0. We do not have to have x1 equal 0. We can find the proportional relationship anywhere on the line. So, next up, we need to do some graphing. You guys are already good at this, so we graph the ordered pairs. This is total pounds recycled, so this is our y. This is days of the month. This is our x. First one. X is 3. y is 36. So we have somewhere between 25 and 50 is going to be 36. It's about 10 more than 25, and which is just a little bit below halfway. So something about there and there. That is our first point. So that takes care of this one. Next one, x is 5, which is 1 more than 4. And y is 60, which is 10 more than 50. Which again is a little bit below the halfway point. Next up, day of the month is 6, which we have on exactly a line. Next one is 72 for y. 72 is almost 75, so we will put the dot almost at the 75. Next up is 7. 7 is 1 more than 6 on the x-axis. And 84. 84 is 10 more than 75, well, 9 more than 75, and 15, well, 16 less than 100, so it's going to go about there. Last one is 12. Notice we are jumping a couple of spaces here, all the way to the 12 on the x-axis. On the y-axis, we are jumping up to 144, so which is almost 150, only a little bit lower. Okay. Next up, we have to explain why the graph is linear. This is fairly easy. We can see that if we drew a straight line, it would touch all of the dots. Why is the graph linear? Well, linear means line. So the graph is linear. A line the graph is linear because a straight line touches all the points. Now, we're going to find all lines have a constant rate of change. If you have a long slope like this, and you've got a little sled up here, and finally kid inside, that little kid will be sliding down just as steep a hill, so long as that slope stays the same, it stays just as steep. So we can find the change in x over the change, we can find the change in y over the change in x here, and it will be the same as here. For any line, the change in x over the change in y is the same at every point. So we're going to find the constant rate of change for this graph. So the easiest way to find the slope is to look for a set of data that helps us. And so we're going to pick one where we have 1 day between our things here, so that makes it easy. Our change in x is just 1 day. So we have our x1 = equals 6 minus our x2, which equals 7. So 6 minus 7, and that equals -1. So, yay, we have -1 there. Y's, we have y1 of 72, y2 of 84. So 72, 84. Let's see. 2 minus 4 is 2. 7 minus 8 is 1. So we have -12. So we have a change in y, which we can write as this little triangle. It means delta. That'll become important when you get to pre-calculus, but for right now it doesn't matter. We have a delta y equals -12. Delta x, which is change in x. Again, important to know when you get to calculus, not important for right now, but of -1. So what is our change in x? -12. What is our change in y? -1. Now, something that I don't know if you guys are ready for this, you're just going to have to take my word for it, is if we have a negative on top and a negative on bottom, we can multiply them both by a -1, and so we multiply it by -1, and we multiply this by -1, and then -12 times the -1 equals, since negative times a negative is a positive, +12, and -1 times -1 equals +1. So what is our slope? Or what is our change in pounds over our change in days? We are changing 1 day, because 6 minus 7 is -1, so, but we changed 1 day. At this point, we'll get to where it's important to have negative slope and positive slope in a little bit. If you only have one of these as negative, so if we had delta y is negative, but delta x is positive, this equals a negative slope. If we have negative delta y, negative delta x, that equals a positive slope. If we have positive delta y over negative delta x, that equals a negative slope. And if we have positive delta y, positive delta x, that equals a positive slope. So, if you only have one negative, you have a negative slope. If you have both the same, you have positive slope, even if they're both negative. Anyway, over here, how many pounds did we change? We changed 1 day, we changed 12 pounds. And what are our points? We chose 6, 72, because remember we always do x and then y. And we did 7, 84. Those are our ordered pairs. So, constant rate of change is, they pick different points. They got 24 over 2. But for us, it is 12 pounds per day. Another way for us to explain negative change in y over negative change in x equals positive slope is that if we take away 1 day, and that means we take away 12 pounds, if we add 1 day, we have to add 12 pounds. So both of these end up being the same thing. This one is just, we're taking away y, so we have to take away x. This one is, if we add y, we have to add x. As long as they're both going in the same direction. Next page. So, again, we see slope is the rate of change between any 2 points on a line. Actually, slope is the rate of change at any point. Never mind, that's calculus, you guys don't need to know it. It becomes interesting when we get to curves. Otherwise, it's with straight lines, it's not that hard. Okay, so anyway, here we can see again, slope is the change or rate of change between any 2 points on a line. Eventually you guys will get to calculus where you're not dealing with lines, instead you're dealing with curves, and the rate of change between points on a curve is also the slope. But you don't have to worry about that until you get to calculus. Still a few more years for you guys. Anyway, slope. Change in y, which I will be using delta y. That is how much vertical change, that's how much it goes up or down, over change in x, which again, I am writing as delta x. That is our horizontal change, how much it goes back or forward. And this graph, we can see that if we go over 1, so our change in x, or no, in this one, we can see that if we start with our y, we go up 2, that is our change in y. So our change in y is from 1 to 3, which is a change of 2. Remember, we don't care that much about where we start anymore. What they taught you last chapter was a lie. We are starting at 1, going up 2, and then we are going over 1. So how much we go up, or our rise, our delta y, is 2. How much we go over is 1. If you solve that, that equals 2. We simplify that fraction. So that means the slope equals 2. In a linear relationship, the vertical change in y value per unit of horizontal change in the x value is always the same. That is what makes it a line. This ratio is called the slope of the function. The constant rate of change, or unit rate, is the same as the slope of the related linear relationship. That is complex words for saying that how much you rise over how much you run equals the slope. The slope tells how steep the line is. The vertical change is sometimes called the rise, while the horizontal change is called run. You can say that slope equals rise over run. And remember, rise is the change, or delta y, and that equals the y 1 minus y2. You can do it as y2 minus y1, and that will keep it a little bit straighter in your head for the positive or negative slope, but it gets a little bit confusing for me, so I do it this way. Over, so this equals rise, change in x, or delta x, equals x1 minus x2 equals run. So, we're going to count the number of units that make up the rise of the line in the graph shown above. Write this number for the numerator of the fraction below. Remember, numerator is the top. Count the number of units that make up the run of the line. Write this number for the denominator of the fraction below. Remember, denominator means bottom. So, how far do we go up? We go from 1, 2, 3, 4. So we go from 1 to 4, which is, we're going up 1, we're going up 2, we're going up 3. So our rise is 3. Our run is going this way. We're going over 1, we're going over 2. That is 2. So our rise over run is 3 over 2. The slope of the line is 3 over 2. Or you can think of that as 1.5. Next page. Okay, next page. The table below shows the relationship between the number of seconds y it takes to hear thunder after a lightning strike and the miles x you are from the lightning. Graph the data and find the slope. Explain what the slope represents. So, here we have miles. We're starting at 0 for both, so that's nice and handy. Our first one is 0, 0, 1, and 5, 2 and 10, 3 and 15, 4 and 20, 5 and 25. So, what is our change in x over our change in y? We go up 5 and over 1. So our rise is our delta y, or our change in y, and that equals up 1, 2, 3, 4, 5. Or if you want to do the math, it is y1 equals 15 minus y2, which is 20. 15 minus 20 is negative 5. So our delta y equals negative 5. Now, so our change in y is negative 5. Now, for our change in x, we are going from 3 to 4. So, this is our run equals change in x equals y, or x1, which is 3 minus our x2, which is 4, which gives us a negative 1. Change in x, since these are both negatives, we multiply them both by negative 1, and we have a change in y of 5 over a change in x of 1. Now, the book wants us to do it as a change of x by 10, and this is a change by 2, whatever, we'll get the same answer. So, change in x over change in y, for us is 5 over 1. We did this as 15 minus 20. And we did this as 3 minus 4. So we had 5 over 1 earlier than they did, and we don't have to simplify, so we have 5 over 1. Only a tricky thing we have to do is remember that if you have a negative over a negative, that we can multiply by -1 and get a positive slope. So for every 5 seconds between the lightning flash and the sound of thunder, there is 1 mile between you and the lightning strike. That is what this means. Got it? Okay, let's do a problem to find out. Graph the data about the plant height for a science fair project. Then find the slope of the line. Explain what the slope represents in the work zone. Okay, so we have our plant height, which is our y. And we have our week, which is our x. So, week 1. Plant height in centimeters, 1.5. Halfway between 1 and 2. Week 2. Plant height, 3 centimeters. Week 3. Plant height, 4.5. 4.5 more. Week 4. Plant height, 6 centimeters. Now, then find the slope of the line. Okay, so we are finding our rise over our run. So, easiest one, 1 week, 1.5 centimeters. So, okay, we are finding the slope of the line, which means we need to find our change in y which equals our delta y, which equals y1 minus y2, and that is over our change in x, which equals our delta x, which equals x1 minus x2, and this is our rise, and this one is our run. So, we need to pick some points. They'll all come out to be the same thing, so I suggest we use the ones that will give us the easiest answer. So, first one we're going to use is this one here. So we plug that one in for our y1 and our x1, because that's our first point. So we have y1 equals 1, x1 equals, or no, y1 equals 1.5, sorry. And then x1 equals 1 minus our y2, which we'll use this one because that's easy. So y2 equals 2. No, not 2. y2 equals 3. Sorry, your teacher's making mistakes. And then over x2 equals 2. So we bring this down, 1.5 minus 3. That's our y1, y2. This is over 1 minus 2, x1, x2. This up here equals a change of negative 1.5. That is a change in y, or a rise. And this is a run of negative 1, or a change in x. That is a run. Remember, since this one's negative and that one's negative, we multiply them both by negative 1. And we can just say it 1.5 delta y is over 1 delta x. What is our slope? Remember, slope equals rise over run. So the slope is 1.5 over 1. Anyway, we can simplify that. We can simplify this by dividing 1.5 by 1. And 1.5 divided by 1 is the same thing as anything divided by 1. 1.5 equals the slope. Over here, you can put 1.5, that is a 5. Equals slope. But what does the slope equal? What does the slope mean? We have to put what the slope equals. Well, what are we looking at? We're looking at plant height over a week. So if we say that the rise is 1.5, what's rising? Well, the plant height. So the plant height is going up by 1.5 for every week. So the plant is growing 1.5, and what is it growing? Is it growing miles? Is it growing meters? No, it is growing centimeters. It is growing 1.5 centimeters for every year, month, nope, week. So, what is the slope? Slope is 1.5. What does that slope mean? It means that we are growing the plant is growing 1.5 centimeters per week. Okay, next page. Problem number 2. Ronaldo opened a savings account. Each week he puts in $300. Draw a graph of the account balance versus time. Find the numerical value of the slope and interpret it in words. So, the slope of the line is the rate at which the account balance rises, or $300 per week. So, if he starts at zero money, because we all start at zero money at one point, he is going to put in $300 every week. This graph only goes up to 80. Oh, that's for the next problem. Never mind. They did it over here for us. We don't have to do anything on that one. Okay, let's check and see if we understand what they're talking about. Jessica has a balance of $35 on her cell phone account. She adds $10 each week for the next 4 weeks. In the work zone, graph the account balance versus time. Find the numerical value of the slope and interpret it in words. This is annoying. They are giving you a problem that they last week told you was not proportional. Now they are expecting you to find a proportional relationship. Idiots. I'll probably have to edit that out. So we are starting with an account balance of $35. So we are starting at 20, 30, a little bit higher is 35. But starting at 35. She's adding $10 a week for the next 4 weeks. So, at the end of week 1, she'll be at $45. End of week 2, because we are adding $10 for this first week. We are adding $10 for the next week. So, she's at 45. We're adding 10 to 45. It gives us 55, which is almost 60. And then for week 3, we are at 65, which is a little bit above 60. And for week 4, we're at 75, which is almost 80. Now we get to graph the account balance, and we are finding the numerical value of the slope and interpreting it into words. So, we are finding the slope of this line. We're finding what the numerical value is. So, for every week, or bringing it over here, so this is my work on B. For every week, she is adding $10. So our change in Y equals $10, which is our rise. Our run, which is our delta X, is what? It is 1 week. And that is our run. Rise over run equals slope. So what is our slope? Our slope is 10 over 1. Can we simplify that? Why, yes, we can. That is 10. So, what is the numerical value of the slope? The numerical value, the slope, equals 10. And what does it mean? We have to interpret it in words. So what does that mean? It means that she is adding $10. She owes $10 more every week. She owes 10 more dollars every week. Hopefully she manages to pay that off at some point, because otherwise it's going to be really hard on her. Next up, guided practice. Okay, so guided practice number 1. The table at the right shows the number of small packs of fruit snacks, Y. So, number of small packs of fruit snacks is Y, per box, X. Graph the data, then find the slope of the line. Explain what the slope represents. So, we have boxes X. First one is at 3. Our Y is at 12. So we go up to the 12. Hey, look, they got a dot there. Next one, our boxes is at 5. The fruit snacks is at 20. Next one, the boxes is at 7. The fruit snacks is at 28. That is our nice straight line. So we need to find the slope of this line. So if we have 3 over minus 5, what is 3 minus 5? Well, sorry. Now we need to find the slope. So first we're going to find the rise. Rise is the change in y. Change in y equals y1 minus y2. We will pick, and that is put over our run, which is our change in x, which is our x1 minus our x2. So what should we choose for our x1 and our y1? Well, let's just pick the first one. They're nice small numbers. So x, which is, remember, up here on this one. So our x1 is 3. Our y1 is 12. we are picking those two. Next we'll do these two. Our y is 20. This is y1, this is y2. x2 is 5. y1 minus y2 equals -5. -5. That is our change in y. x1 minus x2 is 3 minus 5 equals a -2 change in x. So we have a change in y over a change in x of -5 and over -2, which is a rise over a run. Can we simplify that? Yes, we can. We can multiply both top and bottom by -1, and so we'll multiply by -1 times that, -1 times that. That makes those become positives. Now we have a 5/2 equals delta y delta x, and that equals our slope. So find the slope of the line. Slope of the line, can we simplify it any further? No, not really. Is 5/2. I mean, I suppose you could write it as 2 1/2. You could write it as 5.5 equals slope, or you could write it as 2.5 equals slope. Both are correct. Explain what the slope represents. Well, every time we add 2 boxes, we add 5 I messed that up. I bet you guys see the mistake I made. 12 minus 20 is 8. 8. So can we simplify that anymore? Yes, we can. We can simplify that to 8/2, which equals 4/1. You can divide both the top and the bottom by 2. Which we can simplify even further by just saying the slope equals 4. So, if the slope equals 4, what does that slope mean? Well, we have, every time we add a box, we get 4 more fruit snacks. So I think this means that there are 4 fruit snacks per box. Now I'm going to circle my actual answer because otherwise my work's going to get messy. In the future I'll try and do my work on my page over here because that's what where I should be doing it. I want to use the wrong there. That'll teach me for using a pen. Okay, Next up, how is the rate of change related to the slope? The rate of change is equal to the slope. They are the same. Next page. This page I want you guys to try and do on your own, but I will do the first one with you guys because I did that other one, I made some mistakes. So I will do number 1 with you guys. You guys have to do the rest of them on your own. How do we do these? Number 1. The table shows the number of pages Andrino read in X hours. Graph the data, then find the slope of the line. Okay, so graphing part, easy enough. What is our X? Well, our X is time. So X is time, number of pages is our Y. So first one, what is our X? Our X is 1. What is our Y? Our Y is 50. And after that, our X is 2. Our Y is 100. Next one, our X is 3. Our Y is 150. Fourth one, our X is 4. Our Y is 200. So, that is our nice straight line. We need to find the slope. So, remember, slope equals the rise over the run, which equals the change in Y over the change in X, which equals Y1 minus Y2, X1 minus X2. What are we going to choose for our Y1? Well, I suggest we choose the first one. So what is our Y1? Our Y1 is 50. So what is our Y1? Our Y1 is 50 minus over our X1 of 1. 50 minus our Y2 of 100. That is Y1, Y2. And our X2 is 2. So Y1, Y2, X1, X2. Now we need to solve these. So what is 50 minus 100? It is negative 50. What is, that is our change in Y. What is our change in X? Y is negative 1. Change in X. Negative 50 over negative 1. We can multiply both these by negative 1. And that gives us 50 delta Y over 1 delta X. Can we simplify that any further? Yes, we can. If we simplify that further, we have 50 equals our slope, or 50 equals the rise over our run, because this is, remember, delta y equals rise, delta x equals run, 50 equals rise over run, which equals the slope. Okay, find the slope of the line. Slope equals 50. What does that represent? Well, every time we add 1 hour, we add 50 pages. So, what are we doing with these pages? We are reading them. So, Andrino, or Ardino, equals, reads 50 pages per hour. That is a lot. That is very fast. Anyway, I'm going to stop here and let you do number 2 and number 3 on your own. And then you guys can move on with the review stuff on your own as well.